Hi, class. We can continue our study in Chapter 4, talking about triangles and congruence, by moving into Section 4.5. And this section is all about proofs using congruent triangles. So we have two objectives in this section. First is we want to use triangle congruence and corresponding parts of congruent triangles to prove that parts of two triangles are congruent. So what we'll do is I'll give you two triangles and I'll say prove that this part of one triangle is congruent to another part of the other triangle. And we'll just have to go through our two columns proofs to do this. And then the other thing we want to do is prove two triangles are congruent using other congruent triangles. All right, so we have a definition here and kind of an acronym here. So corresponding parts of congruent triangles, right, and thus are congruent. So when we're talking about corresponding parts of congruent triangles, we abbreviate this proof using CPOCTAC, all right, and that's the acronym of corresponding parts of congruent triangles are congruent, right? So that just means if we have two congruent triangles, like if we have two congruent right triangles, the right angle of one triangle A is congruent to the right angle of triangle B, just things like that. All right, so let's do an example here. So talking about using congruent triangles. So we're given this AB, so line AB bisects angle CAD. What that means is this angle then is congruent to this angle, right? And BA, right, this line here, right, bisects CBD, which means that this angle here and this angle here are congruent. So what I want to do then is prove that angle 1 is congruent to angle 2. Right? So the way I'm going to tackle this is I'm going to prove or show that this triangle is congruent to this triangle, and that thus these are corresponding parts of congruent triangles, and they must be congruent. All right, so it'll be a two-column proof. So start with what you're given. AB intersects CAD, right? So what we're going to show here next is that this angle here is congruent to this angle. So angle CAB, this one right here, is congruent to angle BAD, right? The reason being is this is the definition of an angle bisector, all right? So it cuts that angle in perfect half, so the two sides must be congruent. Next, do the other given, so that BA intersects CBD, right? That was given. So then angle CBA, this angle right here, must be congruent to angle ABD, this angle. That is also the definition of an angle bisector. So I've got two angles here, right, that are congruent. These two are congruent to these two. Well, now we have a side that's common among the triangles, right? So side AB is congruent to side AB, right? That's the reflective property, obviously. So what now we're able to say is I have angle side angle of this triangle is congruent to angle side angle of this triangle. So it must be that triangle ACB is congruent to triangle ABD, and this is by the angle side angle postulate. So now I have these two triangles are congruent. So thus, it must be that angle 1 is congruent to angle 2. And the last step we use to say this is because corresponding parts of congruent triangles are congruent. All right. Let's do another one and I'll kind of set it up. All right. So Thales, a Greek philosopher, is said to have developed a method to measure the distance to a ship at sea. He made a compass by nailing two sticks together, right? Standing on top of a tower, he would hold one stick vertical and tilt the other until he could see the ship S along the line of the tilted stick. With the compass setting, he would find a landmark, all right, landmark L on the shore along the line of the tilted stick. How far would the ship be from the base of the tower if he did this? Let me set this up right here like this. So we've got this, here's the tower, there's a ship, and there's a landmark out there, right? So what we want to do is basically use the distance from R to L and show that it's congruent to the distance of R to S. That's really what we're doing. So that I can figure out what this distance is, so thus that's how far the ship is. All right, so here's what you're given. You're given that angles TRS and angles TRL are right triangles, and you're also given that angle RTS is congruent to angle RTL. So think about what's going on here. You have This angle is congruent to this angle. This angle is congruent to this angle. Very similarly, we want to show by extension that this is good. These sides of these two triangles, this triangle and this triangle with the common side, are congruent. So then we'll again use the angle side angle. That's where we're going. All right, so it was given that angle RTS is congruent to angle RTL. Using that reflective property, obviously, side RT is congruent to side RT. That's a reflective property of congruence. All right, angles RTS and angles RTL are right triangles. That was given. So we know that they're equal. All right, angle RTS is congruent to angle RTL, and that's because all right angles are congruent. Obviously, they all measure 90 degrees. Use that angle side angle postulate now. So triangle RTS is congruent to triangle RTL. That's the angle side angle postulate. And then it must be then, since the two triangles are congruent, that side RS is congruent to side RL, and that's because corresponding parts of congruent triangles are congruent. All right, let's do another one. All right, so this is identifying common parts of overlapping triangles. What common angle do triangle ACD, so I have this triangle ACD, and triangle ECB share? Well, if needed, separate and redraw the two triangles. All right, so triangle ACD and triangle ECB. And you can see that they share this common angle C. All right. So given this, try this one. So it's using common parts of overlapping triangles. So given that angle ZXW is congruent to angle YWX, right? That's what this double blue lines mean here, the big angle there. And then angle ZWX is congruent to angle YXW, right? So you're seeing that this little interior guy angles are congruent and these exterior blue angle ones are congruent, right? Let's prove that segment ZW, this segment right here, is congruent to segment YX, this segment over here. All right, since segment X, or excuse me, WX, this one right here, is common to both the two triangles, triangle ZWX and triangle YXW, we can use that information to prove the overlapping triangles are congruent. And then from there, we can prove that segment ZW is equal to segment YX, all right, simply by corresponding parts of congruent triangles. All right, so we were given here that angle ZXW is congruent to angle YXW, that was given. So it must be then that line segment WX is congruent to WX. Let me go back, because they're on the same part of the triangle. Right, that's the reflective property of congruence. It must be then that angle ZWX is congruent to angle YXW. That was also given. So I've got, look at this, angle side angle. So the two triangles are congruent. Right, that's by the angle side angle postulate. And then the corresponding sides here, side ZW is congruent to side YX. That's because corresponding parts of congruent triangles